Okay, Mathboy here, and welcome to this video on the inverse trig functions, differentiating them. Okay, so what we will look at, first of all, is the derivative of y equals arc sine of x. Now, we're not going to differentiate implicitly here, because you can't, but instead we're going to rewrite this as another thing. We're going to rewrite it as x is equal to sine of y. Why are we going to do that? Well, we know the derivative of sine, so we can go dx by dy will be equal to cosine of y. Now, dy by dx is 1 over dx by dy. So if we do 1 over the derivative, so dy by dx will be equal to 1 over cosine of y. Oh, we don't want a derivative in respect to x in terms of y, do I? So I need to figure out how can I find a relationship between cosine and sine. Well, the trig identity is that sine squared y plus cosine squared y will be equal to 1. Now, rearranging and therefore solving, so we get cosine squared y is 1 take away sine squared y. And so, square rooting both sides, get plus or minus the square root of 1 take away sine squared of y. However, is it going to be positive or negative? Well, this is where it gets slightly tricky, determining if it's positive or negative. Now, the reason why is because look at the gradient of the curve. That's the whole reason I drew the curve to the left of the board. Now, if you look, the gradient here is never negative. It's always a positive gradient. And so, therefore, we can get rid of this negative. We just don't include it. So, our derivative, so dy by dx, the derivative will be 1 over the square root, positive square root. You don't have positive out the front. Could if you wanted to, but I'm not going to include it. Now, what was sine of y? Sine of y was x, so sine squared y will be this squared. So, replacing, I got 1 over the square root of 1 take away x squared. And that is the derivative of arc sine x. Now, the reason why it's the positive, because I bet you'll be asking in the comments, is because minus pi over 2 is less than or equal to y, which is less than or equal to pi over 2. That is the domain of this function, of the arc sine. Now, cosine will go between 0 and 1, won't it, yeah? Now, if cosine goes between 0 and 1, well, it's always positive. There's no negative value. It could be 0, it could be 1. You don't know because it's less than or equal to, depending on the domain or the range of z function, okay? So that's what we're looking at here, okay? So it's always positive. Therefore, you have to take the positive root, okay? You can't take the negative, otherwise it's not true for arc sine x, okay? So that's your derivative of arc sine x. Next, we'll look at arc cosine x as a derivative. So, in the previous part of the video, we differentiated arc cosine of x. Now we're going to look at the derivative of arc cosine now. We looked at arc sine before, okay? And I'm going to use the same process. I'm going to use the exact same method as I literally just used. So, we can do both sides. So, x will be equal to cosine of y. Dx by dy, so differentiate. What happens if we differentiate? Well, get minus sine of y. Don't I? Because I know the derivative of cosine is minus sine, that's what you need to remember. So dy by dx. Now, I've seen before that dy by dx is 1 over dx by dy, because you can multiply by its reciprocal. So we end up with minus 1 over sine of y. Now, as before, we're going to look at a trig identity that we know about. Sine squared y plus cos squared y will be equal to 1. Okay? Sine y, well, that will be I'm going to jump straight to the solution because I think you can probably rearrange this yourself. That's plus or minus the square root of 1 take away cosine squared of y. I'm sure you can do that in pretty much one step if you remember it well. So now, is it going to be the positive or the negative? Well, if you want clarification on why this works, arc cosine of x, well, arc cos x is like, well, let's look at cosine first of all. So the graph of cosine of x is like a big hump in the middle and carries on like that forever and ever. There's 0, there is pi. Now, this would range between 0 and pi, and its outputs of sine are 1. Okay? So, all we are saying is that when we are looking at the graph, it's always positive. Well, how can this be always positive? Well, I'm going to need these negatives to cancel out somewhere. Do I not? Or do I? Well, no. Because the negatives don't need to cancel out. Because if they did, that would be a positive gradient. Well, we know that's not true because we know the gradient of arc cosine x from the graph that I drew was negative over there. That's arc cosine, that's the basic of sine, I think that one is. That's sine from memory. Okay? So, what we're going to do is we're going to substitute the positive version. Because the plus and the minus, well, that'll just give me a minus. So we get dy by dx is minus 1 over the square root, the positive of 1 minus cos squared y. Okay? Well, cosine of y was x, so we can put this back in like we did before. Well, x squared is cosine squared y. So that will be just minus 1 over the square root of 1 minus x squared. Okay? And that is your derivative of arc cosine x. Next you can probably guess it's going to be the derivative of arc tan of x is the next one. Okay? Okay, so the derivative of arc tan x, it should be super quick now. So we've got x is equal to tan of y. Dx by dy will be equal to sec squared of y. Dy by dx will be equal to 1 over sec squared y. Trig identity, sine squared of y plus cos squared of y will be equal to 1. Divide through by cosine, so we get tan squared y plus, well, that'll be 1, is sec squared of y. So sec squared is tan squared y plus 1. Okay? Tan squared, well, tan of y is x, so tan squared y will be x squared. We get 1 over x squared plus 1, but it's usually written in the formula book as that, of 1 plus x squared. Okay? Super simple, and should be super quick. Okay? That's how we can find the derivative of arc tan x. Okay, so we're going to look at these 4 questions. We're going to start with number 1. Y equals arc sine of a third x. Well, the derivative of that, well, using the chain rule, the derivative of the inside will come outside, which is a third. I'm going to multiply that by the derivative of sine, which is 1 over the square root of 1 take away 1/3 x whole squared, which is 1 over 3 times the square root of 1 take away 1/9 x squared. And that's the answer to number 1. I'll look at number 2. So we got y equals arc cosine, so we got zy by dx will be equal to the derivative of the inside will come outside, which is 6x, and it multiplies by the derivative of arc cosine, which is minus 1 over the square root of 1 take away 3x squared, which is 6x 1, so it's minus 6x over the square root of 1 take away 9x to the 4, using your index laws. That's number 2. Third one's even simpler. Arc tan x, well, derivative of that, I'm going to have to use the product rule to differentiate that. So, differentiate x squared, we get 2x times arc tan x, plus derivative of arc tan, which is 1 over 1 plus x squared, times x squared. So we've got x squared over 1 plus x squared, and 2x plus arc tan x, plus that. Okay, and that is the derivative of number 3. Number 4, again, you have to use a bit of the product rule. Let's have a look at it. Okay, so number 4, we've got y equals e to the arc sine. Well, e to the arc sine is just one simple function, just the interior and the exterior. So we have to differentiate arc sine, which is 1 over 1 minus x squared all square rooted. And all I need to do now is multiply that by this function here using the product rule, which is e to the arc sine of x. As differentiate e, you get e. Okay, doesn't change. And those are 4 examples on differentiating the inverse tree. Okay then, so we'll look at this problem. We've got a tangent to the curve y equals arc tan of root x at x equals 3, intersects the x-axis at p, find the x-coordinate of p. Okay, well, through this one then, we need the derivative of arc tan. Luckily we've got the formula book, which is up in the corner, so we'll use that. So we will have y is equal to arc tan. Now, root x, using the power law, or your indices laws, would be x to the half. Okay, because it's the square root of x. So, we need to find the derivative then. So derivative, I would have to use, probably the chain rule will be the best bet. So the chain rule would say the derivative of x to the half will be 1/2 x to the minus a half power, multiplied by the derivative of that, which is 1 over 1 plus x. Careful, it's not 1 plus x squared here because it will cancel with each other. Okay, so shall we simplify this a bit because it looks a bit meh. Got 1 over, no, that'll be 2 root x, won't it? Combining those, and then it will be 2x to the 3 halves. So it'll be 1 plus 2x to the half. It'll be 2x to the 3 halves. Now 2x to the 3 halves, using their index laws, well, that'll be a square root cubed, won't it? Which is 1 over 2 root x. In fact, no. Oh, I've gone down a rabbit hole. I'll leave it like that. It's nice enough. So now we want the derivative, so dy by dx, when x is equal to 3. Okay, to do that, so this one I sub in 3 then, don't I? Got 1 over 2 square root 3 plus 2 times 3 to the 3 halves, which is 1 over 2 square root 3. Calculator. Calculator class was fx991ex, of course. Now, I would cube root the 3, and then I would square it. So I'd end up with 3 to the 3 over 2. Which is about 10.39, which is 6 times root 3. So roughly, it's 6 times just below 2, which seems about alright. So it is 6 root 3, which is 1 over 8 square root 3, which you can rationalise. Put that in the calculator. 1 over 8 square root 3 is root 3 over 24. Okay, so we get that. How should we finish this one off then? Well, we need the y coordinate as well, so we need y when x is 3, don't we? Well, that'll be equal to arctan of root 3. Or what's arctan of root 3? Well, that's pi over 3, because it's 60 degrees, don't forget. Because I'm doing all these in radians, so you need to do radians in A-level maths to do this. So the tangent then will be y, take away y1, which will be pi over 3, which will be equal to m, the gradient, so root 3 over 24, okay, of x, take away the x coordinate, which was 3. Now, I would kind of like to find the x coordinate, so I can multiply by the 24 and divide by the root 3, so I get minus 8 pi over the root 3, yeah, which you can prove, of course, which will be equal to, well, that will just leave with the x minus 3, so x will be equal to 3 take away 8 over root 3, which you could rationalise and end up with 3 take away 8 root 3 pi over 3. Okay, and that is the x coordinate of point P.